Okay, now's a good time to get started. So how was everyone's spring break? Good? So? Yeah. So this meeting's a little different because I'm actually some things happened and I'm actually uh, doing this from a hotel room right now, but it's all right. So we have a few things uh, to do today. We have to for those of you that need it, we have to finish looking at the homework that Professor Amir assigned, and you might have already seen the email, but he was nice enough to extend it to the 8th instead of the 6th, and I also asked him if he could extend the due date for the week 9 material to this Thursday instead of today, and he said yes to that as well. So with that, we have two things to do today. One, we got to do this lab, and two, we got to do the homework as well. Which do you guys want to do first? Homework? Okay, perfect. Does anyone still have does anyone have the link to the homework? Because I actually had the PDF of the homework, but it's on my computer back in my apartment, and I'm actually working on my laptop. Can anyone with a link? Can you post that in the chat or something? Hold on. Maybe it's on my email. I gotta check. Oh, never mind. Someone posted it. Okay, let's see. Okay, perfect. Which so we did two problems already. The first one was this one. The second one was this one. And then now we just have to do problem 2 and problem 4. And they both seem relatively easy. Which one do you guys want to look at first? Do you want to look at problem 2 or do you want to look at problem 4? Do you guys want to do 2 first? Okay. Yeah, we'll do 2 first. So 2 says write a function called int count vowels that accepts a string named stir, right? That returns a count of all vowels in the string stir, right? The vowels are A, E, I, O, and U, and they're uppercase variants. Use the helper function is vowel that checks whether a character is a vowel. Okay? Now, the first time I read this, I thought I was talking to myself, oh, we're probably going to have an if statement that checks lowercase a, uppercase A, lowercase e, uppercase E, and then so on. But if we have this, then that actually makes our lives a lot easier. So I'm going to bring Visual Studio over here. Okay. So let me make this big enough so you can see. Okay, so I'm just gonna type our usual C++ stuff. So I'm gonna include IOStream using Okay, so it said make a function called count vowels that returns that accepts a string and returns an int. So I'm gonna write that right here. So we're gonna say int count vowels, and you will accept a string called stir. Okay, so let's do the function first, and then we can test it out in the main function. So we have a string called stir, right? So I already have an idea in mind on how to do this, but does anyone else have suggestions? Like is anyone thinking of the idea that I'm thinking on how to accomplish this problem? I say we're gonna have a for loop that iterates through every character of the string stir, right? So I'm gonna start a for loop. I'm gonna say int I equals 0. I is less than. Now this needs to iterate through the entire size of the string. So I'm gonna say stir dot size. Now I think in order to use this, I need to include do I need to include the string library for this? I'll include it anyways. Why not? String. And then every time we iterate, we'll say I plus plus. Okay. And actually, before this, before we do any checking, we should actually first make an int variable that tallies the number of vowels we see, right? So here's what I'm gonna do. Let's put an int variable right before the for loop. We'll call it number of vowels. So num vowels equals 0, like that. Okay. So now what? So I say inside this for loop, we're gonna have an if statement that checks to see if the character at the index I is a vowel or not. Now, the fact that we have a function called is vowel is going to be useful. So I believe that this function is vowel is going to return a Boolean, right? It'll return true if it is a vowel, and then false if it's not, right? So I'm gonna say if, and now I'm gonna use my is vowel function, is vowel, vowel, and then inside these parentheses, I need to put in the character of the thing that I'm checking, right? I need to say stir dot at I, right? I, like that. But apparently, so it says here is vowel is undefined. So I'm guessing the is vowel function is a member of a library, right? For those of you who already finished the homework, do you know what library the is vowel function is a member of? Anyone? Oh. Oh, you have to make the is vowel function on your own. Oh, I thought it was a part of a library. Okay. So there's actually two things we now make. Okay, so um let's make the is vowel function and then come back to this later. Okay. So this is vowel function. It's going to be a Boolean, right? Okay, and it's gonna take a car called C, right? Yep. And then I'll write the definition here. Basically, we're gonna say if C is uppercase or lowercase a, or uppercase or lowercase b, e, or uppercase or lowercase I, so on, we will return true. But if not, we will return false, right? So I say if C equals a, or this might be a long if statement, but it's okay. If C equals a, or C equals a, or C equals E, C equals E, C, or C equals U, or C equals U. If this is true, return true. And then else return false. Yeah. Because it could be uppercase or lowercase, right? Now I actually have a few errors here. I wonder. Thanks for catching that, Jose Garcia. Yeah, they needed to be double equals because the double equals is the single equals is the assignment operator, while the double equals is the equivalency operator. So so now that I have this, now I can use the is val function. Okay. So if this is a vowel, we will, obviously we're going to increment num vowels by 1, right? So num vowels plus plus, like that. And then after we tally everything, we can simply return num vowels. Okay, so so far I have 2 functions, And I believe this will work now. All that's left to do is to test it, right? So I'm just gonna come up with some strings. So I'm gonna say string 1 equals apple. This should have 2 values because it has an A and an E, right? And then string 2. I should make this word be one that has a different number of vowels. So maybe I'll say banana. So this should have 3 vowels because there's 3 A's, right? So I will, now because count vowels is of type int, I have to treat it like an int, and which means I have to see out it if I want to see its content. So I'm going to say see out count vowels string 1, and then count vowels string 1, and then see out count vowels string 2. So if this program works, when I run this, this should return 2 because apple has 2 vowels, and this should return 3 because banana has 3 vowels, right? Let's see if it works. Yep, it works. Let me make this a little larger so you can see. Yep, so because apple had 2 vowels, it showed 2, and because banana had 3 vowels, it showed 3. So that wasn't, so that homework problem wasn't too bad, right? So it just required us to make some functions and then write the logic for checking the number of vowels, right? So I'm going to make this, I'm going to do this so that you can see everything. Here's the code that you need. Screenshot it or do what you need to in order to get it. But as always, I will be posting this video up on Blackboard after this session's over. But everything makes sense, right? Okay, perfect. So are we good to move on to the next problem now?
Can you check mine?
Sure. Let me stop my share for a second. I'll put this over to my other. Let me. Okay, go ahead and share. Okay, so your is vowel function looks correct. Could you scroll down? Okay. I equals 0 string dot sum. Is vowel. That looks. Yeah, that looks good. What error did you run into? What does it say on the bottom? Oh, it's just not showing anything, huh?
Okay, that fixed it.
It's working now. Oh, what did you do?
I think I just had to hit build and run for some reason.
Okay. Well, it looks like your program is working now, so.
Okay. And did you see the email that a professor replied with that you need to use the global variables in 2 separate arrays for problem 3?
No, I don't think I've looked at that yet. Let me check right now, actually. When was this email sent?
Uh, March 26th.
March 26th.
It should say homework due date now is April 8th.
Oh. Well, I know that he moved it to the 8th. I did get that,
Right.
but it doesn't look like I have an email from March 26th. So he probably only sent it to you. So what exactly did the email say?
So the first part I don't need to repeat it is, you informing him that we need more time, and the second part is because I remember you said you emailed him to see if you did it right, and it says for problem 3, you need global variables in your code. You also need to compare two separate arrays.
Hmm. Okay. Can someone actually forward that email to me? 'Cause I'm a little bit confused. All right. Let me check my email. Yeah. Can someone forward Amir's email to me? Because I don't know. I was under the impression that the solution that we came up with was okay. I'll put my email in the chat. Oh, okay. While I'm waiting for that, do you guys want to look at? Would you guys want to look at question 4 of the homework? All right. Valerie Mora says in the chat, I forwarded. Okay. Thank you, Valerie Mora. I'll look at that after we finish this next homework problem. So, let me go ahead and share my screen again. Okay. So, problem 4 says write a function called. So, this function is going to be of type vector int, and it's going to append. It's going to be called append, and it's going to accept two variables, both of them being of type vector int. And then we're going to call the first vector int A and the second vector int B. What this function is supposed to do is return a new vector int that appends one vector after another. So for example, if A is the vector of 1, 4, 9, and 16, and then B is 9, 7, 4, 9, 11, it'll return the vector this, where the first elements are the elements of A, and the second, and the rest of the elements are the elements of B, right? Okay, so we can do this one too. Now, because I'm lazy, I'm just gonna delete this and then start from scratch. Is that okay? Did everyone already get this code? So I can delete this. Okay. So I'm gonna do that. Okay, so I'll put this over here. And then okay, so this append function it's going to be of type vector int, right? Oh, and because I'm using vectors here, obviously I need to include the vector library, right? So I'm going to go up top and say include vector, like that. Now this is stopping. Yeah, there we go. This function is going to be called append, and it needs to accept two arguments. Both of them are of type vector int. One's called A and one's called B. Now, because I'm lazy, I'm just gonna copy this twice. Call A, comma, B. Okay. So the way this works is I need to return a vector int that's just the elements of vector A followed by the elements of vector B. And we already know how vectors work, right? In case I need to reiterate, so a vector is a collection of data types that are of the same element, like int, right? So this element A has 1, 4, 9, and 16, right? Vectors are very similar to arrays. The only difference is that you can change the size of a vector, but you can't change the size of an array, right? So vectors come with a series of functions. I know that the dot size function retrieves the number of elements. Pushback allows you to add another element to a vector, and then popback removes the last element. And then we also have the insert and delete functions as well. But for this lab, what we're trying to do is create a vector int. So maybe I'll declare a new vector int here. And I'll say that this is the vector that we're going to return, right? Maybe I'll just call this return vector, like that. Now, so at this point in time, return vector is empty, right? What I need to do is take every element of A and push that back to return vector, and then take every element of vector B and then push all of those back into return vector, right? So I already have an idea in mind. Here, this is going to be my solution. Those of you who finished the homework, you probably came up with different solutions, but this is going to be my solution. I say we're going to have 2 for loops, okay? So for. So in this first for loop, the first for loop is going to iterate through every element of A and then push back each element to return vector, okay? So I'm gonna say int I equals 0. I is less than. Now I need this to iterate equal to the number of times of how many elements there are in A. So I'm gonna use the dot size function here. So I'm gonna say A dot size. What this does is that this returns an int value that's equal to the number of elements that's in A, right? Now I'm gonna say I plus plus, like that. Now I'm gonna say, I need to say the vector of the thing that I'm trying to push back, right? So I'm gonna say return vector dot push back. Now now inside of the parentheses, I need to say the element that I'm trying to push back. Okay, what is it I'm trying to push back? I'm trying to push back the element of A that's at index I, right? So I'm gonna say A dot at I, like that. Now you could access the element at A at position I by using this. That's the way that Zybooks does it, but I like to do it like this: A square brackets I. That way I'm treating it like I would an array. But after looking at your Zybooks, I found out that it's more correct to do it like this. So I'm just gonna do it like this. Okay, so this for loop I'll put a comment here, puts every element in A into return vector. Okay, perfect. Now I just need a second for loop that'll push back every element in B into return vector. And now I already have the logic here. So here's what I'm gonna do. I'm just gonna copy these lines, put them here, and change every instance of A to B. Okay. So I'm gonna say, instead of A.size, I'll say B.size, and then instead of A.at, I'll say B.at. So what should happen as a result? At this point in time, return vector will have every element in A and then every element in B, right? So here's what I'm gonna do. All that's left to do now is to return my return vector variable. So I'm gonna say return rt vector. And I believe that's it, right? The only way to see if this function works is if we actually try it. So here's what I'm gonna do. Let's create two vectors that we can append, right? So I'll say vector int, what do we want to call this? Let's just call it vector A. And then we'll make another vector called vector B. Int vector B, like that. So we need to put some, at this point in time, vector A and vector B are empty. So we need to push back some items so that we can populate the members of A and B. So I'm gonna say vector A, not push back. Let's push back some numbers. Maybe I'll say, maybe vector A will, you know, I'm just gonna do the example. I'm gonna do 1, 4, 9, and 16. So I'll push back 1, I'll push back 4, push back 9, and then I'll push back 16. And for B, I'm gonna push back 9, 7, 4, 9, and 11. So let's do that. Let's change this to B. 9, 7, 4, 9, 11. Okay. Nine, 7, 4, 9, 11. Okay. So now I have my vector A and vector B. Are there any questions so far? Did I lose anyone? We good? Okay. So now I'm going to try the append function and see if it works. So maybe I'll say int, oh no, vector, no. let's call this, let's make a new vector called vector C. And this is going to be equal to the append of vector A and vector B. So I'm going to say append vector A, vector B. Okay. So there's that. We do need to see the contents of these vectors. So here's what I'm going to do. I know the homework didn't ask for this, but I'm going to make another function that reads the elements of the array. So I'm going to say, this is going to be a void function. Read back. And this is going to take a vector of int. Let's just call it A. So I'm going to say for int I equals 0, I is less than A dot size, I plus plus, C out, A dot at I, space, and then after that we'll so here's what I'm going to do. I'm going to say C out, and we'll say this is vector A. I'll say I'll call my read vector function. So read vector A, and I'll say C out, and I'll say this is vector B, and I'll call my read vector function again. Valerie Morris says in the chat, do we need to include this code? No, I made this up myself, but I had to in order to see if I had to do this in order to see if the code works, because at this point in time, I didn't see out anything. So I don't know if this function is actually working. Does that make sense? Read vector B, and then C out vector C, read vector Z. So if this works, vector A will say 1, 4, 9, 16. Vector B will say 9, 7, 4, 9, 11. And then vector C will say 1, 4, 9, 16, 9, 7, 9, 4, 9. So let's see if it works. How many of you guys think this will work? You think it will work? Okay, build errors. No, I don't want to. Let's see what's wrong here. Oh, size is a function, so it needs open close parentheses. And that may have been the only error. Let's try that again. And it works. So we got 1, 4, 9, 16, and then 9, 7, 4, 9, 11. And then it says, now it has these two in total. So now we see that this works, right? Let me, yeah, this is, This is quite a lot of code, so maybe I should. Well, it's not really that much code, but so so basically, this is your append function here. Okay, this is your append function. This read vector function here. This is just a function that I made myself just to see if the code works. That's all it is. And then the int main here does everything. And then Logan James Ashbaugh said something in the chat. We could initialize vector A. Yeah, you are right, Logan Ashbaugh. We could have just taken A and then pushed back the elements of B into it. But I just wanted to do it like this, just for the principle of it. And Jose Garcia says in the chat, can you use pushback and C in something? Yeah, you could. Like, is the question you're asking is, can you use user input to pushback and then push back that? And the answer is yes, you can. Yeah, you can do that. Yeah, you can get user input and then push that to the vector, as long as the elements of the vector are all of the same type, like, you know, ints. Valerie Moore says, "Can I see the C out, please?" Are you talking about this?
The actual like C out, like the actual coding of the C out. I didn't get to see it.
Oh, you're talking about the int main, huh?
Yeah.
Okay.
Thank you. So do I need the read vector? Because nothing's showing up on my end without it.
Yeah, because I just go ahead and write this because
Okay.
I only wrote this function to see if it's actually working, and I didn't want to say print every element of A, then every element of B, and then every element of C. I figured I can just write a function and then just call in those two different instances.
Oh, I see. Can you go back up to where it first started? Thank you.
So so are we good on this question now? Do you need more time to?
I need some more time.
Okay. No rush. And you know, as always, this video is gonna be on Blackboard later. Okay. Go ahead and tell me when you're finished.
Okay, I just need the bottom now.
Okay. This?
Yes.
Okay. Yeah. So everyone just screenshot it and do what you need to. So for those of you who did complete the homework already, did you have code that's similar to this? How did you guys solve it? Or was your code like almost exactly the same as mine? Because I'm kind of curious about how you guys did it. Jose Garcia says, I haven't done this yet. I got stuck on homework 3. Well, this is homework 3 though. Are you saying that you didn't do a problem 4 yet? Oh, you were stuck on problem 3, and you didn't do problem 4 yet. Okay. Well, then in that case, it's a good thing that we did this. Okay.
Sorry, can I see the display window again, like the result of it, real quick? Thank you. Okay, I think I did something wrong then.
Okay, I'll stop my share and then we can look at it. Okay, let's see. That looks okay. What exactly did your error say?
Okay, let me just do it real quick.
It looks like it works. But you do need spaces though.
Oh, okay, okay.
Yeah, so go back to your read vector function. So over there,
Hold on.
yeah, on your read vector function, there should be a space between those. There you go.
Okay, I wasn't sure about that.
Yeah.
Okay, I'm so sorry about these minor causes. I'm sorry.
Right. Okay, perfect. Let me go ahead and share my screen again. Well, dang. Here's the thing. We have exactly 4 minutes left in this session. And because we did spend this much time on the homework, let me pull up this. We were actually supposed to look at the week 9 material because it is due on Thursday. And yeah, so I was actually kind of hoping today that we could get the homework out of the way as quickly as we can, and then do the lab. But we are running short on time. I don't know, like why isn't the chat window showing? Oh. Homework today isn't due until midnight Thursday. Okay. Yeah, but the week 9 material is going to be due 5 p.m. Thursday. So we should try to like, even if we go over time, I think we should try to get this out of the way. So I won't normally do this, but I'm gonna do it here. I'm going to go over time, but if any of you guys need to, like, if you have like other schoolwork or other things, you're free to leave because don't worry, I will post this video on Blackboard later, right? But I'm going to take the time now to do the 9.8 lab. Okay. So, and those of you that need to leave, that's fine. You are welcome to do so. But those of you who want to stay and do the lab, you can. And then those of you that leave, you can just get the lab 9 from the video after I post it. Does that sound good with you guys? Because there's not going to be another meeting before when this lab's going to be due. I don't know. How do you guys feel? You guys want to do that? Okay. Can I assume that you? Okay, great. All right. So I don't want to spoil the fun of solving the problem. Have a good night. Okay. Bye, Jose Garcia. Oh, oh, yeah, Valerie Moore. I was just saying that because this lab, this 9.8 lab is going to be due 5 p.m. Thursday. I was going to do it, and then, but if for those of you that need to leave, you can leave and just watch the video later. Does that sound good, Valerie Moore?
Yeah, I was just wondering.
Okay. So let's try to do this as quickly as possible. Well, actually, first, I should have said this first. So I did send an email to you guys over the break asking you to do the week 9 sections by yourself over the weekend. For those of you that did do it, was there any sections that you guys wanted to look at? Or are we just good to do the lab? You're good? Okay, great. All right. Let's do this lab as quickly as possible because I already looked at it and I already know what to do. And lucky for us, this section didn't have that many labs, as you can see. Like there was 3 that I can choose from that I can choose to unhide from you guys. But I looked at them. 9.6 looked like it required a lot of work. So did 9.7. 9.8 was the only lab that I felt like you guys could do. And that's why I decided to unhide this one. But let's go ahead and start looking at it now. So 9.8 says playlist, output linked list. So given the main function, complete the song node class to include the function print song info. Then write the print playlist function in main.cpp to print all songs in the playlist. Do not print the dummy head node. So if the input is this, apparently the input has 3 different songs. So each song has 3 different variables. One is the title, the length of the song, I'm guessing in seconds, and then the artist. So this is the song title, the length, the artist, song title, length, artist. And then the purpose of the -1 is to indicate to the program that there's no more data to read, right? So if the input is this, it'll output list of songs, title, length, artist, so on and so forth. Now, there was a whole section about linked lists, right? So am I okay in assuming that everyone knows what a linked list is and I can proceed to the lab? But basically what a linked list is a linked list has 2 parts. One is the information that is part of that node, and then the other part is a pointer variable that points to the very next data item, right? So that's the way that linked lists work. Okay. Now, we actually have 3 files here. One is the main.cpp, right? So the thing that we have to do with the main.cpp is write this print playlist function, right? But if you clicked on this downwards arrow here, it'll show the other files that are associated with the program. One of them is songnode.h, and .h means header file, right? So this .h file contains the header file for the entire song node class. So I know that we haven't talked about classes yet in this class, or Or have you? Did Professor Amir talk about classes? Or not yet? Say in chat if yes or no if he discussed classes yet. Yeah? Oh, you can't remember. Okay. Well, that's okay. You don't need to know that much about classes for now. Just know that a class is just it's a very powerful form of I don't want to say it's a data type, but we use classes to group together not just variables, but also functions associated with those variables as well. So it looks like this class called song node has 4 private variables, string song title, string length, string artist, and then here's the pointer variable that points to the very next item, right? So it contains 4 private variables, but it also has some functions that are public, right? Now I could go over the difference between private and public, but that's kind of outside of this the understanding of this lab. Right now, we're just focused on writing those 2 functions, right? But I'm in the future, I can tell you about classes. So in the public section, it looks to me like it has 5 different functions under public. So one of them is this constructor here, right? This is a constructor. This is a constructor. This function called insert after allows us to add new songs to the linked list, right? The function called get next allows us to retrieve the next song. And the last function here is called print song info. That's actually the function that we need to write, right? So the header file simply contains a list of the members of the class. If you wanted to see the code of each member of the class, you would actually have to click this arrow and go to songnode.cpp, right? So this is the code for the constructors. This is the code for insert after. This code is the code for the get next function, which allows us to see the next song. But as you can see, we have a to do here. And if you go back to the main.cpp, there's a to do here. So in order for us to complete this lab, we actually need to do 2 things. One, we need to write the print song info function for the song node class, right? The second thing we need to do is go to the main.cpp file and write a print playlist function that calls the print song info function from the song node class so that we can print the songs, right? So it's those 2 things. Well, what do you guys want to do first? Do you want to do the main or do you want to do the song node CPP?
I think in order to actually solve the main function, we need to do the CPP function first.
The CPP function or the song node?
No, the song node. Yeah.
Okay, that's what I was thinking too. Okay. Okay, so this is gonna be this is actually not gonna be too hard. So so in order for us to do this, I'm actually gonna go back to the header file and I'm going to copy this line. Well, actually, let me zoom in so you guys can see on the video. So here's what I'm gonna do. I'm going to go to songnode.h. I'm going to copy this line, okay? So copy that. So and after that, I'm going to go to songnode.cpp. And I'm going to post that here. Now that I have the name of my function, there's actually a couple things I got to do because this is a function definition now. The header file contained the list of members, but the CPP file contains the code that's in each member, right? So in order for me to type this, I actually need to do a few things. The first thing I got to do is remove the semicolon like that. And then the second thing I got to do is I got to say the name of the class : right before the function name. So I'm going to say song node : like that. You're going to learn this when we discuss classes, but the purpose of this song node : is to indicate that print song info is a function that belongs to the song node class. That's all it means. Okay. So, and as always, because this is a function, I need to put squiggly brackets here and say what it does. Okay. So, in order to print the song info, that's actually kind of easy. So if you recall before, if you look back at the songnode.h file, it only contained 3 variables. Well, it actually contains 4 variables, the 4th one being the pointer variable. But the first 3 is the only 3 that we care about. We have the song title, the song length, and the song artist, right? So in order for us to print the song info, all we need to do is output those 3 member variables one by one. So here's what I'm going to do. I'm going to go back to songnode.cpp. And then I'm going to, how does it want us to output this? It says title : space, then the title, length : space, then the title, artist : space, then the title. And then after all that, we should finish the line. Because I see this empty line here, right? So here's what I'm going to do. I'm going to, because it needs us to see out those things, I'm going to say see out title : space. And then second, I need to print the title of the song. Now, here's the problem. Because this is a linked list, I can't simply say song title like that. I have to do something a little different. What I actually need to do is say this, and then the arrow symbol, the arrow token, and then song title, right? So I have to say this, pointer token, and then song title. Do you guys understand why I need to have this here, or do I need to explain it? Okay, so I don't need to explain why I need to have this here. Okay, Logan James Ashlaw says a refresher would be nice. So the keyword, the token this refers to, it refers to the, because a linked list is multiple entities, we can't just say song title or song length or song artist, because there's multiple entities on the linked list. And which one are we referring to? The this variable refers to the song title variable of the node that we're currently looking at. So we have to say this pointer song title. That's the best explanation I can give. So after we say this, we can end the line, and then after, my knowledge on pointers is not, it's kind of fuzzy, but that's, yeah, the this pointer token, it's exactly the same as, because I told you before that I was learning Swift programming language on my own. It's exactly the same as self dots, but the C++ version of referring to yourself is this arrow. I just thought I'd share that with you. So the next thing we got to do is we got to say C out. And the very next thing I wanted to see out was length, right? So you're going to say length colon space. And I can't say song length. I got to say this song length. Song length. And then I'm going to do the same thing for the last member, which is artist, right? So C out artist. Well, that's how I did it in an example, right? Yeah, it is. So artist, this song artist. And that's actually all there is to type in the songnode.cpp file. That's it. We just needed to add these lines of code. So now that we have this, we can go back to the main function and then call it there. So if everyone already got these lines of code, I can switch back to main.cpp. Because we've already typed everything that we needed to in songnode.cpp. Am I good to switch pages? You got it? Okay, perfect. All right, so I'll go back to main.cpp. Right. So now all we have to do is write the print playlist function. Let's remind ourselves what exactly it is we're trying to do. So it reads this data and then outputs this, right? Complete the song node class to include the print song input. We did exactly this just now. Then write the playlist function in main.cpp to print all songs. Do not print the dummy head node. Okay. Okay, so now we have to write the print playlist function. Now, here's what I say. I say that the print playlist function is going to be a void function. Why? Because we're not returning any sort of data. We're just outing each node's individual elements, and that's a process, right? So I'm going to say void, and then the name of my function is going to be print playlist. Like that. Now, in order for this function to work, it needs to take an argument, and that argument needs to be the linked list that we need to pass to it. So, in order for us to do that, we need to say it needs to accept a variable that's of type song node, right? Song node. But at the same time, it also needs to be a pointer variable. So I'm going to put the dereferencing operator here. The dereferencing operator is the asterisk, okay? And now, lastly, I also need to give this variable a name. Well, this variable is going to be my list of songs. So what do we want to call this variable? Do we just want to call it the list or list of songs or something? It doesn't matter what we name it. I guess I'll just call it list of songs. And that should be fine. One sec. Okay, so it's gonna take a variable, a pointer variable of type song node called list of songs, and then now we simply need to write the code that that'll print each node, right? So here's what I'm gonna do. I'm going to make another song node pointer variable. And call it current. And I'm going to set this equal to list of songs. Pointing to get next. Now, the purpose of this is that the purpose of this line of code is that do you remember what it said here? It says, do not print the dummy head node. So what I did here was I set current to equal to list of songs, but I proceeded to the very next node, right? If you want to know what get next does, it does tell you what it does in the songnode.cpp. But basically what it does is that it moves you to the next node, right? That's all it does. So going back to the main.cpp, now that we have that, we're going to continue traversing the node currents until the very next pointer that we're pointing to is pointing at nothing or null. Because when we get the next element, if the next thing that's pointing to is null, that means we've reached the end of the list, okay? So I'm gonna write some things here. So we want to keep traversing the list until we reach null, right? So here's what I'm gonna do. I'm gonna make a while loop. So while current does not equal null, right? And null is a keyword. Okay. So while we're not looking at null, we're gonna call the print song info function, which is the very function that we wrote, right? But we can't just say print song info. We can't just say that. We actually need to say current pointing to print song info, because print song info is a member of current, which is a type of type song node. And then after we print the song info, the very next thing we got to do is move on to the very next node. So So here's what I'm gonna do. Does anyone know how to set current equal to the very next node? Does anyone have a suggestion?
Do you have to use the current and then the pointer and then get next?
Yes, that's exactly what you have to do. Good. Thank you for that. So we have to say current equals current pointing to get next. like that. Okay. And that should be it. But I feel like we do kind of run into a problem here. At the end of, here's the problem. You know, these labs make you, in order for it to be correct, you need to finish you have to put an NL at the end, right? So I think here's what I want to do. I want to say we need to end the line every time we finish a song, because there's a line here, and so on. So here's what I'm gonna do. I'm gonna say if current does not equal null. If this is true, we'll just end the line. See out, end line, like that. And I think this will work. What do you guys think? I know I threw a lot at you just now, but I hope this makes sense. So to recap everything, we made a print song info function in the songnode.cpp, and then we wrote a function in the int main that calls it, right? How many of you think that this will work? Well, there's only one way to find out. If we, Christopher Gutierrez thinks it'll work. Well, thank you. You have more faith in myself than I do. Okay, let's try it. Yeah, and it works. There it is, 10 out of 10. So the input is these, and then we call, Michael Rubio Cruz asked, did we do anything to the header file? No, we did not. The only things that we modified is the main.cpp and the songnode.cpp. But yeah, apparently it works. So if the input was this, -1 indicates you've reached the end of the list, and the output's this. Okay. Yeah, so that's all you need to do. So let me zoom back in so that you can get this. You needed to write this function in the main.cpp, and you needed to write this print song info function in the songnode.cpp. Those are the only two things that you have to do. But yeah, does anyone have any questions? I know I've gone way over time, but well, what would you guys say? Are we good to wrap up this very long meeting?
Can you see the main file again, please?
Sure. Yeah. This is the only thing we added. And as always, I will I'll post this video up on Blackboard later. Are you good?
Hold on.
Okay. Okay, Valerie Morris says in the chat, will we finish problem 3 on Thursday? Mhm. Oh yeah, that's right. Because your homework is due midnight of. So we can take time to talk about it in the next meeting. Oh yeah, if you guys want, we can finish discussing problem 3 on Thursday, and I can look at the email that you guys forwarded to me. Is that something you guys totally want to do? Okay, perfect. So we'll do 2 things on our next meeting. One, we will finish looking at problem 3. And then 2, we can start looking at the week 10 sections. But what do you guys say? Are we good? Did everyone already get this code? Yes? Does anyone need to look at the songnode.cpp again? Or no? Okay, perfect. Let me go ahead and stop my share. Okay, so if no one needs anything else, I will go ahead and wrap up this meeting, quickly post this video on Blackboard, and then I'll see you guys Thursday. All right, I'll see you guys.
All right, thank you.
All right, thanks for coming. Bye-bye.